This video will help you with the topics on homework number 10. The first topic is plotting points and graphing functions, and you'll need a TI-84 calculator to help you do this. So the first equation given to you here has an x value and then a power of 2. Anything with a power of 2 is known as a quadratic. So what we're going to do is we're going to turn our calculator on, and we're going to type this function right here into our y equals button. So make sure you've cleared out anything that's there, and then you type it exactly how you see it, 2 parentheses x minus 1 parentheses exponent of 2. And from here, you can find some points in the table of values by pressing second graph. But before we do that, let's just take a look at what the graph should be looking like. So when I'm done plotting my points, I should have this nice soft U-shaped curve. It looks like it's touching the x-axis at around point number 1. It looks like it's touching the y-axis around the point number 2. So that's probably something I'm going to see when I click second graph to look at my table. Now again, you can move up and down this table by clicking the up and down arrows. And I see here I've got -2, 18, but my graph only goes from 10 to -10. So that's not a plot point I'm going to plot, so maybe I'll plot -1, 8, 0, 2. So -1, 8, click it, 0, 2, click it, 1, 0, and 2, 2, 1, 0, 2, 2, 3, 8. Look, I'm seeing some symmetry here. Do you see how these are lining up? Because quadratics make a parabola and they have symmetry, with an axis of symmetry right down the center. So 1, 2, 3, 4, 5. Plot at least 5 points, which I did. So now I'm going to click Done Plotting. And now I'm going to draw a function with my mouse, or if you have a touch screen, you can certainly use your touch screen to kind of draw like that. You see how I missed that point? See how I missed that point right there? So I'm going to erase it and try again. And usually for me, I find when drawing quadratics, it's kind of starting down here is usually a little bit more helpful. So I'm going to use my mouse because I couldn't really see when I was using my finger. And then you have to come all the way up until you see an arrow. You see how that arrow appeared? You need to come all the way up till you see that arrow. Now this looks a little funky here. So I'm going to undo that last part and try one more time. That does not look any better, but alright, let me try one more time. It's a little tough. I don't think they're as particular about the line as they are that you have arrows and that you go through every point. So I'm going to submit my answer and let's see how I did. Yes. All right, so they have some dotted lines. See, I wasn't exactly perfect, but it was good enough. All right, let's try this one more time. Again, I'm going to take out my calculator. I'm going to go to my y equals button, delete out anything or clear anything that was there before. Now this one is a cube root. Now if you don't know where that button is, it's in the math feature here. This math feature, you'll see it's option number 4. That's the cube root. All right, so I'm going to press enter, and there we go, cube root of x. Now don't forget to get out of this cube root sign. You don't want to have that +2 underneath that bar, right? You don't want that. So I'm going to delete those and make sure I get out, and then write +2. Let's see, what's our graph going to look like? So we kind of have an idea. Ooh, it's a little of a funky curve, right? A little sideways curve there. So let's take a look at our table of points. See if we can't find something reasonable. So -1, +1, 0, 2, and 1, 3. And then these are kind of not very friendly. So I'm going to go up, 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 up. See if oh, there's another one. -8, 0. -8, 0. And now I'm going to go the other way and see if I can find a friendly point again. Probably at +8. There it is. +8, 4. +8 and 4. All right, so now 1, 2, 3, 4, 5. I plotted 5 points. And now I'm going to start connecting by drawing this way to get my arrow. And then that way, get my arrow. This is a little wonky down here. Let's see if I broke any rules. Oh, they gave it to me. Look at that. It wasn't even that perfect. And I still got it. All right. So that's how you're going to use your TI-84 to help you graph some functions without being given a table. And now we're going to go on to section 2, transforming formulas. So I've been working on this for some time. Hopefully you're feeling confident with these. Isolating for a given variable. So let's see, our first one is a density formula. Figure out what letter you need to solve for. Solve for V. So V happens to be located in the denominator. The only way to get it out is to multiply. You need to multiply by V to both sides. And now I can get V by itself. And now to get V by itself, I have to get rid of timesing by D. So I'm going to divide by D, giving me this fraction when I'm done. V is equal to M divided by D. Submit. All right, let's take a look. All right, swinging of a pendulum. It's a pretty funky formula, but again, we only need to concentrate on what we're solving for. Solve the formula for L. Okay, we're solving the formula for L. So right now I have T equals 2 times pi square root L over G. Now I cannot get rid of this square root sign, which L is trapped underneath, until there's nothing outside of the square root sign. So the first thing I need to do is get rid of this timesing by 2 and timesing by pi. So the opposite would be to divide, and that would give me T divided by 2 pi is equal to square root L over G. Now I can undo this square root sign. The opposite of a square root is a square. So I have to square both sides. That's what makes the square root sign disappear. So I'm going to write it up over here. This is what I have now. This entire side is being squared, so I'm not going to square it. I'm just going to say that it would be squared. And now I can isolate my letter G. So I need to get rid of isolate my letter L. If I want to solve for L, I need to get rid of dividing by G. In order to do that, I multiply both sides by G. So this is my answer. This is my answer over here. So I'm going to type, you can even type all of these parentheses too. Whoops. Parentheses G, parentheses, capital T, fraction bar, 2, and then I'm going to click this button pi. And then to get that power, I have to press Shift 6. Shift 6. And now I can try submitting my answer. Woohoo! That was a tough one. Okay. Again, the formula here asks you to solve for F. And if my formula is T equals 1 divided by F, you cannot have your variable in the denominator. So I'm going to multiply both sides by F, giving me F times T equals 1. And now I'm going to get F by itself by dividing both sides by T. So F is equal to 1 over T. That's what I'm going to type here in my answer box. 1 over capital T. Whoops. 1 over capital T. All right, let's go back to our third topic here on interval and inequality notation. This one is an interesting one here because it says that I can either be, on a number line, less than or equal to 8, which looks like this, or I can be greater than or equal to 0. So you see how these two arrows are going in different directions? So interval notation for that would have to be two separate things. So I'm either negative infinity to negative 8, or 0 to positive infinity. All right, so I have to have an or in the middle. You have that option here. but they ask you to write it in interval notation. So my first one is parentheses and bracket, negative, negative infinity to negative 8, or bracket parens 0 to positive infinity. All right, we'll submit our answer here because I had 2 inequalities. All right, now for this one. See this funky symbol? That means it's the union. That's a giant U for the union. So if we're looking at this, we're thinking on a number line, okay, negative infinity to 3. So I can beat all of this up until here. And then from 6 to positive infinity, I can beat all of that. So I can be this and this. I can be this and this. So because these 2 sections don't overlap, I'm going to have to write 2 separate inequalities. I'm going to have to write that I can be anything that's less than or equal to 3, or I can be anything that's greater than or equal to 6. So this is inequality notation. So here I'm going to type, using these inequality symbols up here or on my keypad, x can be less than or equal to 3, or x can be greater than or equal to 6. Now remember, I need these greater 2 signs because these were brackets, right? Those were closed brackets. All right, let's try another one. All right, I'm going to sketch this out so I kind of have an understanding that I can be less than 5, that's what this says, or I can be greater than 9. Right, see these? But I'm not in between those things. So I can either be this or I can be that. So I'm going to need 2 interval notations. I can be from negative infinity, oh, that was terrible, negative infinity up to 5, but I cannot be equal to it. Or I can be around 9 up to positive infinity. So I'm going to need 2 double parens here. So I'm going to type double parens or double parens. Whoops, yikes. Double parens or double parens. And now I'm going to fill in my values. Negative infinity to 5 or 9 to positive infinity. One more time. All right, express this inequality using interval notation. This is a very simple one. If I were to sketch this out, I can be anything that's less than 4, but it cannot be equal to 4. So I don't need an or union symbol. I'm just anything that's less than 4. So I'm going to need 2 parentheses because infinity never gets a bracket, always gets parentheses. And this circle would be open. So there's our final answer. All right, let's go back and take a look at this last topic, which is new this week for us, conversions. Now remember, when you are converting, right, you're going to use this here. And when you're converting, you're always going to be multiplying one thing by another thing, right? So let's see here. 6 years. So I have 6 years, and I want to make that into hours. I have 6 years, and I want to make that into hours. Now, I don't know how many times I'm going to be multiplying, but that's my goal. 6 years into hours. So, the only way for years to disappear is for years to be from the numerator and canceled in the denominator. So what fact do we know about years? We know about years right here on the chart is 365 days. Well, technically it's 365 and a quarter, but I guess they're rounding. So we're going to say 365 days, 365 days equals 1 year. Now I can cancel out the word years. But I don't have hours. I have days. So I need to multiply by something else that I can convert, maybe, right? I want days to disappear this time. I want days to disappear, but I need to have a fact about days and hours. So I look down here, and there it is. 1 day is 24 hours, and there I have it. So now I'm simply going to pick up my calculator, and I'm going to type this math conversion in. So it looks like I have, let's quit out of here, get back to our main math screen. We have 6 times, and we can use the fraction button if we want to. Now all of our denominators are 1, so it doesn't really matter for this problem, but they're not always 1s. So we just like to type what we see. Again, another fraction, 24 over 1. And now we have our answer. 52,560 hours. 52,560 hours in 6 years. So we're going to type that down here, 52,560, erase all this, and click submit. All right, let's try another one. Remember, the goal is to cancel out whatever you have, 7,100 minutes, and we want to turn it into weeks. And the only way for that to happen is for minutes to be times by another rate from the chart, where the minutes has to be in the bottom. Okay, so do we have anything with minutes to weeks? No, the only thing we have is minutes to seconds. So it looks like I'm going to get seconds up here. So the conversion is 1 minute is 60 seconds. Ooh, that's crazy. I'm getting smaller. I don't want to do that. Seconds will not get me to weeks. So we need to rethink that. Do I know anything else about minutes? Oh, yes. Here's another one. I know that 1 hour is 60 minutes. So 1 hour is 60 minutes. There's the cross-off that I want, but hours are not weeks. So I got to do another multiplication here. Let's see. I want hours to go away. And what do I know about hours? 24 hours is 1 day. Okay, so let's fill that in. 24 hours makes 1 day. So that makes my hours disappear, but I'm still not at weeks. Still not at weeks. I'm going to move that over a little bit, weeks. So looks like I'm going to have to multiply by another rate. Can I get days to go away and weeks to appear? Yes, here we go. Oh, no, that's 1. Oh, yes, 7 days. So I'm going to put that down here. 7 days is 1 week. There's the cross-off that I wanted. And there's the units. Right, weeks. We finally made it. So we're going to now pause. We're going to pick up our calculator. And we're going to type all of these fractions. So I've got 7,100 times this fraction, which is 1 over 60. Then I'm going to times again by this fraction, which is 1 over 24. Then I'm going to times again by this last fraction. Whoops, I'm in the wrong place. Gotta get out. That times sign is in the wrong place. There we go. And now we're going to times by 1 over 7. Okay, there we go. Yikes. That's crazy. Another way I could have done it was a single fraction like this. 7,100 times all the other numerators. Times 1, times 1, times 1. Okay, I probably didn't even have to write that. Oh, sorry. I forgot to fill in my denominator. And then this one was a 1. Okay, 60 times 24 times 7. All right, and then we convert that to a decimal. And that's what we get, 0.704. What does it say here? Answer. No, you must use these exact conversions to get this equation. Oh, to the nearest, I forgot. To the nearest 100th. So we're rounding to the nearest hundredth. So if I go back to my calculator, that would be 0.70. Because 4 is not big enough to round me. That's the hundredths place right there. 0.70. Alright, let's see. Yes! Alright, that was a tough one. Let's do one more. Convert 7,800 yards into kilometers. 7,800 yards into kilometers. Okay, so 7,800 is yards, and I need yards to go away. And I'm going to write all the way over here, I want kilometers. So, I've got to use this table. What am I looking for? Anything with yards in it. Okay, it's nothing with yards and kilometers, so I'm going to turn yards into... So let me find it here. Okay, I want kilometers. So this one has kilometers in it. This one has kilometers in it. Okay, so I either have to get to meters or miles. I either have to get to meters or miles. I think I'm going to go to miles because these are customary units. So I'm going to go from yards to feet. So there's 3 feet. There's 3 feet every 1 yard. Okay, so that gives me yards disappearing. Now I want feet to disappear. So here's another one. I've got 5,280 feet in 1 mile. So I'm going to write that in here. 5,280 feet makes 1 mile. So now my feet have disappeared. Now I need my miles to disappear. And let's see, I've got right here. 1 mile. 1 mile is 1.609 kilometers. Bingo! I've got there. Okay, great. Now my miles cancel out. All right, now I'm going to use my calculator. I'm going to do what I did last time. Where, whoops, don't get that 2 off the screen here. Hold on. I'm going to make one giant fraction. Let's see here. One giant fraction. And in my numerator I need 7,800. So 7,800 times 3 times 1 times 1.609. Right, that's everything in the numerator. Now denominator I have 1 times 5,280 times another 1. I guess I don't have to write those, but I did. All right. It says round to the nearest hundredth, so this is the hundredths place where the 3 is. The number next to it is 0, so it doesn't round me up. It's just going to be 7.13. 7.13. Whew! All right. Well done. That was tough, but I know you can do it. Good luck.